That was cool, huh? That's the new technology. I've really got to get better at this. That was an intro video. Nobody. I mean, I'm sure Deshaun was like, "Hey, you should use intro videos," and now I understand what he meant. It's a little awkward that I didn't know that. Anyway, we're joined by the legendary Rossen Stoyanchev. How you doing, my friend?
Very good.
Good to see you. Happy holidays to everybody who's joining us again on the stream here. Look, we just got Spring Framework 7, huge release. I wanted to talk to you very quickly about some of the features in that release. Obviously, there's too many to count, but the thing I've been talking about and using and playing with a lot is the declarative sort of interface clients, HTTP.
Yeah.
And so you worked on that, and yeah, you don't really need an introduction, but just in case, can you introduce yourself?
Yeah, of course. I'm Rossen Stoyanchev. I've been on the Spring Framework team for many years, going back to Spring Framework 3.1 was the first release I worked on, doing some refactoring for Spring MVC with Arian, learning the ropes.
You said 3.1?
3.1, that's right.
But I've known you for a lot longer. 3.1 came out in 2009 or 2010.
2011 to be precise. Yeah, so before that I worked on Webflow.
Okay.
Right. So I started in engineering around 2009-10, working on Webflow initially, which is what sort of paved the way for me to work on the web in Spring Framework, because, and of course, before that, I was doing training and consulting, Spring teams, seeing a lot of Spring teams, and yeah, that was a different time, but I really enjoyed it.
Okay, now I'm starting to. Okay, now I understand. I was gonna say I've known you for a lot longer than just that, and I remember you were doing stuff. You know,
yeah. So since then, I mean, the Spring Framework has been my home. I've done lots of things. There's been many phases and evolutions. We've had, the async and the streaming coming in,
right.
then the reactive space. Now, more recently, we're back to imperative and Loom and sort of new challenges around that. But there's always interesting stuff to spend time thinking about.
Do you ever get back to Spring Payment Services?
Oh my goodness, that is the most frequently question asked
I'm
that
sure.
I don't know how to answer.
Okay. Okay. Well, look. So the new. Okay, I wanted to talk to you briefly. I know your time is limited, and so I wanted to briefly talk about. Yeah, I mean, you have 4 really nice features in the new release. There's we mentioned the thing I've been using all the time, the HTTP clients. I'm a huge fan. API versioning. I've also been talking about that all the time. And then HTTP service client config. Obviously, that's I think that's a kind of an extension of the HTTP client stuff. And then the REST test client support. So 3 things, 3.5. Where do you want to start? Actually, can we start at the declarative? I call them declarative interface clients, whatever. But that thing has been so long in the making.
Yeah.
What is it?
So basically going back to Spring Framework 6, actually, Rewind, we introduced interface clients. That is something that existed for a long time in Spring Cloud OpenFane, more than 10 years. And that's where you can create an interface that looks like a controller or expresses the same annotations as on a controller. But you combine it with a proxy factory, and it gives you something that you can use to make calls to the server, which is super convenient because I think many times the way you want to use HTTPs by exercising a Java API with given types, as opposed to, of course, in this approach, you have to create the types yourself, the input and the output types. But it's quite easy to put together these interfaces and get started on making calls without using REST template, REST client, web client directly. So that gives you, something that's built. I mean, this was fine for a long time, existing in Spring Cloud, but they reached a point where, they wanted to make some changes, support the web client. So we talked about it, and it was a good opportunity to bring that into the Spring framework, which we did. And we thought we were pretty much done, but there was one area which small area that was not done, and that's how do you actually configure all these clients? Because what actually happens is that when you have these interfaces, you end up having quite a few of them
Yeah.
potentially with you, because you're talking to a lot of services, microservices. You need to make these remote calls, and ideally, what you want to do is you want these to be Spring Beans. So it's just an interface. It needs to be passed into a proxy that gives you into a proxy factory that gives you the proxy. But then you also want to turn it into a bean so you can inject it into your code and you can
All right.
use it to make calls. And yeah, so that was an issue that hadn't been solved, and we started looking into that, and of course, the what you want is for that bean to be generated transparently, right? You just want to say, here's a bunch of interfaces. I want them to talk to these servers through these REST clients. Just make them beans. I don't want to
Yeah.
do it by hand for every single one.
Right. So you're talking about the developer ergonomics, sort of like the Spring Data repositories. You just define the interface,
Yeah.
and with a minimal of fuss, they can
And
be turned into a.
actually, there are multiple problems hiding in this
Oh, yeah.
simple requirement. Multiple problems hiding.
Simple.
The first one is how do you actually create all those beans? Because usually with beans, you lay them out in your configuration, but here we have a dynamic set of beans. We need to point to a bunch of interfaces and turn those into beans.
Yeah.
So that's one particular challenge. So the original approach of Spring Cloud OpenFeign was the Feign client annotation, which you would know. You put that on the interface. But we looked at that roughly a year ago is when we started, and the first thought was that putting a lot of attributes on that annotation means that it's not quite as centralized as it could be, right? Because a bunch of these interfaces could be sharing the same client underneath. So ideally, you want to declare these interfaces and then have a client associated with them. Otherwise, with an annotation on the interface, it basically sets up a situation where you've got one interface, one client, next interface, same another client. There's no way to actually group them at that point, because to group them, you really have to start by saying these interfaces are all talking to the same host. They're all going to use the same client. So let's make them a client and then associate it with those interfaces, and now we can make the beans from that.
Nice.
So we looked into that. So we said, okay, if it's not the Feign client annotation, then how is it actually going to work? And the next thought was, well, we can make a programmatic registry as the basis, and then we can add annotation support on top of that. So we started going down that road, but we realized that there's actually a chicken and an egg problem, because in order to create those beans, actually the Spring application context needs to know about them pretty early in the life cycle, because when it's doing analyzing cycle dependencies, it needs to know what are all the beans that I need to use in order to work out how they depend on each other. So if in order to create one of these beans, interface proxy beans, we have to actually initialize a REST client and do the whole thing, that is going to pull in a lot of dependencies too early in the life cycle, causing loops.
Yeah.
We realized we needed to do something different. So we went through multiple phases and finally came up with a sort of import-like declaration, like something similar to an import annotation. So you say @import HTTP services, and then you can do a component scan to find them. You can declare them explicitly on the annotation, and then once you have those groups, there's a way to actually then initialize the clients for them, and out of that you basically get all these interfaces as beans that you can inject, and it works quite nicely.
Nice. Just from a purely background perspective, could we have implemented that on top of the bean registrar stuff, since it is a 7.0 feature?
That is a very, very good question, because that came around the same time, and we actually looked into that. The catch there is that is an even more basic mechanism, so it
Yeah.
doesn't actually get annotation metadata. Remember, what we have is the at import HTTP services, which tells you where to go scan, and you actually want access to that metadata, those attributes, so you
Right.
know where to find these services. And the bean registrar operates on a slightly lower level, doesn't actually get that level of detail, doesn't get
Okay.
that information.
Super cool. So I mean, this is the kind of
Um,
stuff where when it works well, it really works, and I'm glad you did that.
yeah,
Um, so
yeah,
now you can just so the simple case is import HTTP services, point it to an interface or an array of interfaces, and that'll work. Optionally, if you want to specify allocations of REST clients or REST templates, do we support that?
hmm
And web clients.
Well, no, not for the for interface clients, yes, but not for the auto configuration.
Okay.
That's REST client only and web client.
Okay. So if we want to specify which clients are allocated to which interfaces, we can use the configurer.
Yes.
And that's a group. There's literally a concept of a group, so you can say.
Yeah. So once we call it the group and say these are the interfaces by scanning, give it a name like, my host, let's say.
Yeah.
Then you can create a configurer that lets you then work on the underlying client and HTTP service proxy factory if you need to work on one or both.
Yeah.
And you can customize a whole bunch of things, and all of that belongs to the group, which then is associated with these interfaces. And this group configurer is something which I would compare to a customizer in Spring Boot, like a client customizer.
Yeah.
But it's in Spring Framework, and it's associated with this, and it is something that Spring Cloud can plug into. It is something that Spring Boot can plug into. Spring Security plugs into it. So all of these are not just can, but they actually do in these
Yeah.
latest releases, which now becomes a powerful sort of initialization mechanism, because Boot brings in the properties, right? So previously, until now, you could say Spring HTTP client, and then provide properties and actually configure the underlying HTTP client. Now you can do that for multiple clients, one for each group, and you have these properties. So this is something very new and I think quite powerful. Spring Cloud comes along, does the same thing, but for cloud-related configuration.
So load balancing, client-side
Load
load balancing
balancing, yes, and you can
resolution,
go group by group, configure this in your properties.
right?
And then, in addition to these properties, you can actually write your own configurer and then further help to initialize the client and the Spring Security does that, and the reason it does that is because it looks at a client registration ID annotation on
Right.
the annotated interface,
Right.
and that plugs in OAuth support right out of the box.
And what I love about Spring is it's just a loose constellation of well-designed components. So Spring Security's interceptor simply sets an attribute, which
Yep.
then gets sent to the configured interceptor on the
Interceptor, and on during as part of the request, it takes your
OAuth
identity,
client.
finds your identity, and then inserts the necessary credentials. I do want to mention something actually here that comes up as a question often, because if you think about, for example, the fact that sometimes these interfaces are not hand coded, right? You would use Open API, for example, and generate the interfaces. So that's one thing that we had in mind with the external import that finds your interfaces. But often people wonder, if I'm using Open API, that actually gives me fully working functional client code. So do I need all of this stuff, and what do I actually need it for? And I do want to point out that yes, Open API will give you a lot of those capabilities and will actually generate the types, the input and the output types, which is quite appealing. However, once you can have Open API generate those interfaces,
Right.
But then from there, you can actually rely on the proxies that we create instead that OpenAPI generates in order to run the clients, because of this initialization mechanism, which is actually gives you a lot of powerful ways to initialize the underlying client infrastructure, right? So there is multiple things going on here. There's the input and output types. There is the declaring of the services as beans, and then there's the initialization of the client infrastructure. You can use OpenAPI, but then we can help alongside that by discovering these generated interfaces with their types, input and output types, and we can help to turn them into beans. That's the one major benefit. And then the second benefit is you have really powerful ways to initialize the clients underneath, which is actually many times I've heard from people say that is actually the hard problem. It's less. Sometimes people don't even mind creating those beans, however they do, but the client infrastructure is something that's becomes difficult to manage when you have to manage that many targets and SSL, security. There's all kinds of aspects that
the OAuth dance. I mean, all this is fun. So that's a huge deal. And by the way, all that works in GraalVM as well, and it's reactive as well, and perfect. There's also two other features, really big. API versioning. I've been doing demos on this. This is kind of like Stripe style API versioning, and it's. I mean, I've seen. It's not a new idea, right? Use a header or use a parameter. Use something from the client to route to the right version of the endpoint. Why did we add it now? What was the motivation? What was the last straw?
Yeah, it's interesting. Actually, the thing that actually kicked it off was an issue in the issue tracker that was relatively minimal. It wasn't like super extensive and justifying why we should do it.
Right.
It was just a very simple declaration along the lines of, hey, it sort of works, even points to an article that shows how to do it with Spring MVC, but I'm not satisfied. Doesn't go far enough.
Right.
So we looked at that, and the first thought is, well, this is a slightly difficult topic because there's so many opinions. Some people even say you shouldn't do it. There's so many ways to do it. There's no standard to do it. Is this really something that you could look at that and say that's a reason not to do it, right? Not to get involved and it's easy enough, just do it. But then it's also a reason to try and step in and provide some basic foundations and help to do to make the right thing easy.
Right.
So looking at it from that point of view, we didn't want to take opinions because actually there's many different applications and not all of them have the same needs. Some of them have a lot less of a need for API versioning. Others, you can sustain without change much longer, and you should. But we wanted to make sure that if you have to do this, and it is actually a very, very common practice, then it's available. I will tell you that after creating this, we were surprised by the popularity of the feature. I mean, it just, it became the most popular topic at Spring I/O, as you know. And that is something that just showed the level of interest that was there, where we thought we were fulfilling something that was relatively easy to do, but in practice there was actually plenty of things to do, both on the client and the server side, and very happy that we decided to do it.
Me too. Hugely beneficial thing. And we have, we on the Spring team, we try to, I think we do a very good job of saying, hey, this is where you should go, as opposed to where people are, and so, we have really good efforts around hypermedia. We have really good efforts around, we are contract first. We've always been that way. We don't want people to have incompatible APIs. We want them to think about their contract and all that. But at some point, the world is not.
Remember, there are nuances. I mean, if you look from a very high level, you could say it's just a matter of a few mechanisms, a strategy. But actually, when you start to take a closer look, you realize that depending on which strategy you pick, there are different specific things. Well, I'll give you an example. If you use path-based versioning, The
Right.
version is built into the path. And because every endpoint has a path, it's not something that can be optional. You can't say you either have a version or don't have a version. You have to decide on that, and then it's present in your path. So it's a pretty wide across the whole site. If you look at header or parameter version, that doesn't have to be explicitly present in every endpoint, right? You could mark some, let's say, one endpoint and say, this is actually a newer version, and here's another endpoint with the previous version, but everything else is the same. So that sort of sets up a different way of thinking about how do you express the version
Right.
on the endpoint, so you don't have to go put the version on every single endpoint. Then you have a new version, you have to go change it everywhere. Whereas when you do that with path, that's actually very naturally in the path variable, so you don't have to do that all over the place. So yeah, getting into that level of detail, getting a little bit of an opinion on directions, like what makes good practice and not. I think that side is also something that's appreciated
Huge.
by users.
And it has again, one of the nice things about Spring is that there's layers, right? So this has a knock-on effect for Spring Cloud and Gateway, right? We can reuse that similar infrastructure for API versioning, sensitive routing.
Yep.
That's
Yep.
cool. Okay, a last one here before I have to let you go. Well, the REST test client, like, huge. I don't know why I've been waiting for this for, like, I didn't know I wanted this, like, so bad until it arrived. I'm like, oh, that's so good. What is that?
Yeah. So in a nutshell, the REST test client is a facility that uses REST client internally, but it gives it a different shell. So up to the point of making the request, it looks just like the REST client, and it's actually calling the REST client all the way through underneath. But once you make the call, then everything from there is focused on testing. So, for example, you have assertions, you have a workflow that's aimed at different ways of asserting. Maybe you want to go look at the body, maybe you want to do a JSON path, maybe you want to assert headers, status. So providing all these options is there. And also, if you want to, you can use it. This is another difference. So instead of necessarily calling a server,
Yeah.
You can actually do this without a server with mock MVC. And so instead of creating a client factory to connect to a server, we actually create a client factory to connect to mock MVC. So there's no server. So we just translate into server-side mock MVC request and response.
Right.
We make the call, and then we bring that back. There are other benefits. For example, we cache the response, so you can actually read it multiple times. And this was important, for example, for Spring REST doc, because when you're documenting your API, you want to exercise it, and
Right.
then you want to actually record separately what was the response. You want to get the content of the response so you can create the documentation, or the REST doc can create it.
Right.
So that ability to read the response more than once was important. So it provides things like that out of the box. And then one more thing that we did for REST client, which I think is really worth mentioning, and it actually we did for web test client as well, which is that we now have AssertJ support for both of them. So one option is you can use REST client and you can make the call, and then you can continue in a chain. And, for example, that allows you to convert into an object and then, compare the object, decode as a client. But you can also exit quite early, and then you create this response assert, and then you start doing this. You have all these options to do this with AssertJ. So if you are, for example, familiar with mock MVC tester that we added in a prior release, 6.2 maybe, which is basically AssertJ support for mock MVC. Well, it shares a lot of API surface with that, but this is with REST client underneath. And we did the same thing for web test client. So both of these things are available. But really, I mean, the REST test client, up to that point, the answer was web test client, which you can use with mock MVC. So you can say
Yeah.
mock MVC web test client, and mostly you don't actually really need to know or use Webflux or Flux, because it is built to be blocking. So your assertions are still blocking style. So the convenience factor is there. But the requirement was, let's use REST client internally, the exact same infrastructure as we use in production.
Right.
So that was one reason to create REST test client. It makes sense. It's something that we needed to do. Of course, with web test client, you can do a bit more because you can test streaming using Flux. So if you have SSE endpoints, and then web test client is still the thing. But yeah. So at the moment, we have mock MVC web test client and REST test client, which directly overlap with each other.
Right.
I think at some point we will probably phase out the mock MVC web test client, because REST test client should be the answer there for now.
It's so good.
That's yeah.
That's so good. Was that designed in? Did you work with Sam on the REST test client, or is that just
So actually, that came pretty late in the cycle. It wasn't originally something that we were planning to do, and actually, it's a great story. Somebody from the community in Atlanta, Georgia, I think, stepped in and sent a pull request that was actually pretty complete in terms of what needed to be done. Of course, we went through multiple iterations, so even if it's complete, such a major contribution, it's difficult to get it right from the start. So we went through multiple phases, and then there were plenty of things that we had to add afterwards, to make it to what it is now. But
right.
That initial start was very important, and the pull request was very much appreciated, because it really provided quite a bit of the initial work that was needed.
Well, and it also demonstrates a demand, right? Like, this is what I love about our community. When people send pull requests, they're providing two things: a demonstration of a need, and code to help supplant the need. That's a wonderful synergy.
Yeah.
Well,
I should actually, one other topic that's
oh yeah,
worth mentioning is um, that we have announced some plans for the REST templates. So that's there is a blog post on this. There's actually a whole roadmap to GA series blog post. There's one on state of HTTP clients, it's called. So that takes you a bit through the history of our clients, because we started with the REST template and the web client. Now we have the REST client. And we've reached a point where, we want to eventually deprecate the REST template. But I think reading the blog post will give you good context. The short story is that, the REST client is a sort of a modern API on top of the same infrastructure as the REST template, so they are equivalent in terms of capabilities. Where the REST template falls short is that because of the template methods, they've become so many. There are now a number of things that we cannot easily build into it. So if you talk about API versioning, for example, there's no easy way to bring that in, because if you want to insert a version, where do you put that version on all the template methods? That becomes a challenge. Whereas with the Fluent API, we just add a version method once, and it's conveniently available when you build requests.
yeah.
So there's a lot of things. There's actually a number of features that are mentioned. De facto, the REST template is falling behind, right? And it's not because we don't want to keep it up to date. Well, for once, we don't want to maintain two different clients that do exactly the same thing. But at the same time, we realize that the REST template has been around for a very long time, and it works. And it's not something that we're in a rush to phase out immediately. So the plan, as we've announced it, is that we're making it known that we want to deprecate it. We will officially deprecate it in 7.7.1 to be removed. It's going to be marked for removal, but the actual removal will come after that, probably Spring Framework 8, which is a date to be determined. That's not yet known.
Well, I owe Rodrigo Graciano an apology. I was sure we would never deprecate the REST template, but here we are. Either way, makes sense. I get it. I use the REST client all the time anyway. The REST template. I've got a fair bit of code using the REST template, but it's pretty natural to migrate that stuff, and I'll just do that. That'll be fine.
Yeah, I mean, over time, eventually, as much as we're attached to certain parts of the code, or that they're in use, eventually we have to sort of encourage move forward. And as I said, I mean, over time, it just falls behind. Now we're getting into new topics, and this is actually an interesting one to mention as well, because it's a bit forward-looking. So Loom is great, right? So that gives us, and structured concurrency will give us a way to deal with concurrency. But there is one piece which is something that we've gotten accustomed to, but it's actually missing in all this new stuff, which is the ability to stream with Loom and structured concurrency. There isn't. So if you look, for example, at the JDK HTTP client, that is using the Java util concurrent flow, essentially the reactive streams contract, the publisher subscriber. So we're talking about what is the equivalent of that in a Loom world. What is the equivalent contract? And clearly there are some preferences. For example, pool style API is supposed to push more like iterator and less like publisher pushing into a subscriber.
Right.
But to combine all of this with Loom and structured concurrency to make sure the propagation of signals, if you have an active producer filling a blocking queue and then a consumer reading from it, like a channel in Kotlin or Flow, how do you propagate signals? So all of this is infrastructure. I mean, if you look at REST template, streaming was always basically you can get an input stream or output stream, and then if you really need to do streaming, the answer was always, you get those and you do what you need to do. We didn't have like a built-in SSE converter or anything like that, right? Then came reactive and streams and RX Java and all those patterns and web client. It made it easy and natural to do streaming. So you get a flux and you operate on the flux, and that gives you lots of capabilities. So I think in those interim, however many years, it became the norm that if you had to do streaming, there was a good way to do streaming, and there was something equivalent to the Kotlin flow, right? Now the REST client replaces the REST template, and we're picking up from where REST template left off in terms of streaming. So we're down on the level of input stream and output stream. But actually with AI and MCP, there's a very strong need for facilities for streaming. And we don't provide anything out of the box for SSE. And if we did, well, we could do something. But how well aligned is it going to be with what's going to come from the JDK? So this is an area that we're looking into. And I think it's important to acknowledge that the expectations these days are, I need to be able to do what I know I can do with Flux. How do I do that in a Loom world with structured concurrency? So that is yet to come, but we're trying to make inroads in that direction so that we can use something while eventually it comes from the JDK, but that's going to be, in the future.
Awesome, and I can't wait for that. Rossen, thank you for this amazing release and all the work you've done. Thanks for hanging out in the show and answering my my many questions. And thanks everybody for joining us today. Hope you learned something. I certainly did.
Thanks, Josh.
Thanks. Bye-bye, everybody.